Hello, world. So here we go. This is a second lesson on ideal gas, and we're going to do some data analysis here. So as you can see, I've successfully modeled an ideal gas here. And I know that I've modeled an ideal gas more or less successfully because my velocity is constant-ish. So we've got a lot of fluctuation going on here, and that's problematic from a science perspective because which of these data points should we use? It's not necessarily obvious, right? And we don't want to be arbitrary about it. We want to be methodical. So the way that we're going to do this is first just clear data, and I want a fresh data run here. So I'm going to let this run for 20 or 30 seconds. I don't need like 20,000 data points, and letting it run for 30 seconds is going to produce, as you will see, a few thousand data points by itself. So plenty of data. Okay, so after I've let it run for a while, what I will do is go to Save as CSV file. Okay, and that's going to export a data file that we will then open in Excel. So if you go to Show File, it'll actually show you where your new file is located. And then you will want to open it with Microsoft Excel. I've set it to the default for CSV files, but you may have to go digging a little bit. Okay, so we're going to open it in Excel, and it looks like this. We have time in the left-hand column and speed in the right-hand column. We're not really interested in time right now, although the increment of time might be useful, I suppose. What we're instead interested in is the speed column, okay? So in order to analyze this, the first thing I'm going to look at is average speed, okay? So you will want to copy these column headers. And in the average speed column, I'm going to hit equal sign, and then I'm going to select all of this data after I type AVG average. There we go. Okay, I now need to select the range, so I'm going to pick this first data point, and then I'm going to hold down Shift and Command and push the down arrow, and that's going to select all of the data immediately. Cool, right? Okay, you then hit enter, and now we have the average of that data set, several thousand data points, just right there. Boom. Okay, so this is my average speed then. For average kinetic energy, why don't we just move this over here for a while? Okay, we'll come back to that. What I would like to look at instead is the procedural uncertainty of this average measurement. So the first thing we need to do is find the maximum speed. So the maximum speed will be given by an Excel function where we take our maximum value of this range. And again, we hit Shift, Command, down arrow, and enter. And that gives us the maximum range. Another thing we could do is just copy this for our minimum, paste it in, and then we'll change the name of our function to predictably min. Okay, so there's our minimum, there's our maximum, and for procedural uncertainty, we're going to do one more function. Okay, equal sign, maximum minus minimum, and we need these to be in parentheses. Okay, we will then divide this with a backslash by 2. Okay, and this gives us the procedural uncertainty of this data run. Now, uncertainty is always to one significant figure, which you should remember from last year and previous lessons. So our procedural uncertainty in this case is plus minus 0.01 meters per second. Okay, which is considerably less certain than these enormous numbers of sig figs we see here. Okay, and that's just due to the fluctuation. If we go back to our simulator, you can see fluctuating, fluctuating, fluctuating. Not good. Okay, so back to Excel. If we want to calculate the average kinetic energy of our particles, which is actually very important, we need to take the formula for kinetic energy, which is 1/2 mass times velocity squared, and type 0.5 asterisk for multiplication. Our average speed, well, actually, let's, before we do that, let us look at the mass of our particles. Okay, so we find the mass of our particles simply by picking one and right-clicking and going to Information. And you can see here my particles have a mass of 0.010 kilograms. Your mileage may vary. Okay, so we will put in our mass, 0.01 kilograms, and then multiply that by our average speed squared. And there we use a caret to indicate an exponent, just like your TI-84 calculators. Okay, hit enter. And now we know our average kinetic energy in joules. And if we wanted to, we could apply this uncertainty to this value as well. But we can talk about how to handle uncertainty of calculated values in another lesson. Okay, hopefully that all made a lot of sense, and I will see you guys later.